Hello there. Today we'll be doing Sudoku Validator. Sudoku is a puzzle where you're given a 9x9 grid with digits. The objective is to fill the grid with the constraints that every row, column, and box and 3x3 grid must contain all the digits from 1 through 9. And numbers shouldn't repeat within a row, column, or box. Given the filled out Sudoku board, return whether it's valid or not. So to do this, I believe we should take every single item in this matrix and put it against the test to check every row, the column, and the box for that particular item. This way, we check all the possibilities at which it could be wrong and whether it could be right. I'm sure that there might be a way to maybe speed up the process, but who knows? But this is the most straightforward process, and we're gonna code this up. Okay, so to do this, we need to know what a valid list looks like. So we're gonna set this to I for I in range of 1 through 10, not including 10 because it goes up to 9, up to 10. So it only goes 1 through 9. So we have a valid list. And we want to check for I in range of, let's say, 9, because we're going to go 9 spaces, and J in range of 9, we're going to go 9 columns. So is valid. We're going to check if this particular position is valid. If it is not valid, then we're going to return false. Otherwise, return true. So let's define the valid function. We're going to define the valid function inside our function because this way we can pull in all the global variables given to us. Yeah, so like the matrix and the valid list, we pull those in. So all we need to put in is the row and column. So the first thing we need to check is if the row of this particular item is any good. So sorted, matrix. Interesting. If we check do we need to check the row 9 times? Can't we split this up and check the row? Yeah, I think we can split this up. Yeah, but we still need to check every item. But we can skip this check if the row is valid. So I think we can split this up into 3 different portions and like just check all the rows, check all the columns, and check all the boxes. We can even flip the matrix to save space, so save time by flipping the matrix. We can, by transposing, we can even just check this using this one validator. Yeah, but in the interest of time, we're just going to check every single row multiple times. So if the row is sorted and it's not equal to the valid list, then return false. Otherwise, we're going to create this to check every column. So this goes every row and checks the entire column, adds all those numbers in, and if the sorted of these nums it does not equal valid list, return false. Lastly, we need to do one more thing, which is to get the starter start row start, and column start. to get this, we need to have the row floor it by 3, then multiply by 3. By flooring it to 3, we get 3 choices. If it's in any of the 0, 1, and 2, it would give us 0, start at 0. 3, 4, and 5 will start at 1, and 6, 7, and 8, it will start at the 2. 2 times 3, and which is 6, and then start at 3, and so on and so forth. So this will get us to the correct spot of starting. So we do the row start, and we're going to do row start plus 3. We're going to move 3 spots. Where this could go up to, but does not include. And after that, we just fill in the nums, not append all the numbers. And make sure that's valid. Okay, after all of that, we just return true if it's valid. So that's it. Run. Oh, row could not be defined. Ho, ho, ho. What happened here? Number 27. I and J. I see. Accepted and run. Perfect. And that's all you need to validate a Sudoku puzzle. There are some optimizations, like I said. We could just do all the rows once and all the columns once, and we can just do is valid box to check all the boxes for every item in the box. Or we can check each box to see. You can reduce these this operations by a whole lot. There are optimizations that we can make, like just checking each particular box as well. But I think, like, yeah, there are many optimizations but we can make, but still over one operation here. It's just 81 times 27. That's the number of operations we are making. But reductions that can be done is that when this is going to be 9 and 9, and this is going to be checking each box, which is not also 9, so which is 27 times, which is 81 times faster if we do this with more code. I think this is good enough for now as a proof of concept, and I do think that maybe we can investigate into this this solution of looking into 27 checks, 27 different checks. Well, 27 times 9? Yes, 27 times 9. So, yeah, do we want to do that? It's already 8 minutes and 45 seconds. I think we can. Okay, here we go. So, first of all, let's just check the rows, and then we'll just check the columns. So this is going to break up the problem some more. So that takes care of every possible row. Okay, let's take care of every possible column. So that basically means copying this, and yeah, just making sure they're all equal. So we're gonna reset our nums at the new column. Okay, and now we're down to our last problem, which is the I and j. So how do we get the start point for each row and column properly? So it's, well, we can either, like, we can just add it in. You can just make starts. Row starts. Well, row starts and row columns are actually the same. So starts are going to be 0, 2, actually 0, 3, and 6. So for I in starts, for j in starts, number, looks like it's gonna reset after each start. Yeah, so it looks really messy. Maybe a run, maybe it won't. Line 26. Oh, row, what's going on there? I, or we can just change this to row. I'm actually pretty not confident in this, and we don't know what the errors are at this point, or where we failed. So print rows checked. This is going to be a debugging session. I don't know if you guys are down for that, but if you have any comments or questions, please put them below. If you enjoyed the video, like and subscribe. The continuation of this video is just me debugging this particular solution, and if you don't want to see that, then that's that. That's okay. Then we're done. Then we can be done here. I see that this is not in the right place. Let's run it again. So columns are checked, rows are checked. The only thing that's missing is the boxes checked. As you can see, this is gonna take a long time because it's not pretty. It's definitely not pretty. So it starts at 0, 0, 0, 3, 0, 6, 3, 3, 3, 3, 0, 3, 3, 3, 6, and then 6th, 0, 6, 3, and 6, 6. It should start at the right place. So the start should be correct. Oh, I see. This is the problem. K and L. And wow, okay, looks like we have succeeded here. Interesting. Let's submit. Maybe we got it. Maybe. Oh my gosh. Oh my gosh. Okay. Looks like we've done it. This is as fast as we can go. And we have done it. We have completed the problem. So let's zoom back out. Let's delete this code. This is how we check our rows, check our columns, and we check our boxes, and that's it. Amazing. Amazing, right? That is crazy. Okay, perfect. All done? Well, thank you very much for watching, and have a good one.